So in this talk, I'll be mostly talking about some of the key microservices integration patterns. So I have a couple of slides, and then I'll quickly jump into my use case implementation with Ballerina. So why integrating microservices, right? So one of the key requirements for realizing microservices architecture is the plumbing between the services that you are developing, right? You are building a microservices-based application as a set of service, and those services has to communicate with each other to realize a given business use case. And all these services are dispersed within the network, so all the integration has to happen over the network. Now, we used to do this kind of integration in the ESB era with a central service bus architecture, right? So you have set of services, APIs, data, and systems, and you had the enterprise service bus layer, which is orchestrating, coordinating, and providing all the inter-service communication resiliency capabilities. Now, with microservices architecture, what you have is you don't have an ESB. What you have is, again, a set of service. So you have microservices that are talking to each other, and inter-service communication and the resiliency has to be part of the services that you are developing. So that's why microservices requires some unique technologies to realize these requirements, because conventional programs are not necessarily developed to make your network interaction easier. Right? So one of the we can identify several patterns when it comes to microservices integration. Right? So in this case, I'm using synchronous messaging pattern where we have a set of services. So you can identify different types of services. So here we have core or atomic services, then we have composite services, and when you want to expose some capabilities to the external parties, then you have API services, which are managed by a central API management layer. So when it comes to developing, for example, this service, you need to have quite a few network interactions. A service that talks to several other services in request-response style. And so there can be business logic, data transformation, application of enterprise integration patterns, as well as the inter-service communication resiliency, like circuit breaking. Right? Now, the second pattern is obviously asynchronous event-driven communication. Right? So in this case, a given service is actually dependent on all the downstream services, right? Because it is using request-response style communication. And when it comes to asynchronous event-driven messaging, we have a central event bus, and you are mostly using single consumer or multiple consumer messaging, queues or topics, right? So in this case, services are mostly loosely coupled, autonomous, unlike the services that we have in the previous architecture. Now, so let's try to, so those are the two main patterns that we usually use in microservices integrations. And let's take a simple use case. And one other thing is, when it comes to implementation of this synchronous messaging, there are multiple protocols, right? Obviously, RESTful and HTTP is the de facto standard for building this kind of protocols. But we are seeing quite a few usage of gRPC and protocols such as GraphQL and like high-performance protocols such as RSocket when it comes to building this kind of patterns. And for event-driven messaging, again, Kafka is possibly the most commonly used technology. And you have quite a few AMQP brokers such as RabbitMQ, ActiveMQ, to build this kind of pub-sub communication. And there are cloud-native technologies that are emerging, such as NATS, which is a CNCF project, which is, again, can be used as the event bus. And also the different types of specifications are emerging in this area, such as cloud events, to basically cater this kind of messaging architectures. All right, so in this use case, we have an online retail scenario where we have multiple services, right? We have one portion which is asynchronous communication, one portion is event-driven communication. So here we have the services that are exposed to the consumers are mostly based on REST, right? So catalog service is based on a REST. It can be REST or GraphQL. So here I'm using REST for my use case. And the catalog service actually talks to two different other services. So here we have product info and inventory services. And for internal microservices communication, it is gRPC is most commonly used because you need to have high performance inter-service interactions within the enterprise. So here we have used gRPC in this use case. And obviously, these information can, these services can have their own databases. And the databases can be, again, based on different technologies, right? You can use MySQL, MongoDB, or depending on your services requirement, you can select whatever the database type you want. And on the asynchronous side, we have a checkout service, which is actually, again, getting messages from the consumer and immediately return back response back to the consumer, but creating an event in the Kafka broker. And there are two subscribers to the same topic. One is a shipping service. Again, it has its own database. And one is an order processing service. And as part of the order processing service, we have integrated with file system, because as you know, there are a lot of file system integration related use cases, which I create a CSV file. So this is like this is covering pretty much most of the patterns and wide range of technologies related to building microservices interactions. So I'll walk you through on most of the how you can build these links and how Ballerina is providing a seamless way on integrating with all these technologies. All right, so okay, you can see. Okay, so now let me start with my catalog service, right? So we have, it's a REST API. So I have defined an open API or Swagger definition for the service, right? So I'm using the contract first approach. I have defined the service definition using Swagger. So let me show you the definition. Okay, let me. Okay, so this is my Swagger definition of the catalog service. So I don't have the implementation yet. I only have the service definition. Let me quickly show that in the Swagger editor. So it's a simple API. We have products, get, post, and you can get products by product ID, right? All right, so let's now let's try to do let's try to implement this service using Ballerina. So for that, we can actually use the Swagger definition to generate code, generate Ballerina service skeleton. So the way that you can do that is, here I have a project directory initialized with Ballerina in it. And let me run the command. I have it in my, yeah. So the command is, yeah, I hope you can read the command. So you can do Ballerina. So I have installed Ballerina in my environment. Ballerina Swagger mock. And then you can give the OpenAPI definition YAML or JSON file, and then you can give the service name. So I can say catalog. Okay. Now it has generated the code service skeleton. Let's go and check the code. Now, if you look at the Swagger definition again, so we had several types also defined. So product is the type that I have defined with these properties, right? Now let's check our service implementation. So everything is generated code. You can see I have given, in my Swagger definition, I have given localhost 9090, and in my generated service, you can see there's a listener created, HTTP listener for Ballerina created with the given details. And then you have Swagger annotations. And you can see these are the services, service-based path, and there are multiple resources created for each resources that we had in the OpenAPI definition. And also, we can see the types generated. So these are the types, because I had product as part of my OpenAPI definition. So these are the types that we have created. And actually, you can directly run this service. So the implementation of these resources are actually done. So if you look at, let me go to the get product details resource. So you can see in the Ballerina code, it refers to another function, right? Show product by ID function, which is defined in another file. So this is the place that you are going to edit, right? So this is the sample response that it has created. Now let me quickly run this and show you. We haven't done anything. It's just a dummy implementation. OK, so service is started. Let me quickly copy the curl command. OK, so it's getting the hard-coded response, which is automatically generated by the CodeGen tool, right? So again, going back to the use case, what we have done was we have just created the catalog service skeleton, right? We have the OpenAPI definition and service skeleton code generated in Ballerina. Now, the next step is to implement these product and inventory services. Now, here we have to use gRPC. So with gRPC, you can take two approaches. You can do either code contract first approach or code first approach, which means you can start with gRPC interface definition language. You define the service using the IDL and then generate code. Or Ballerina also support, you can, the code first approach where you generate the code, where you write the code and generate the interface definition. I'll show you the both of those approaches. Now, let me go to the product info service. So this is my gRPC definition of my product info service, right? So here we have, again, very similar to the OpenAPI, but I have defined the protobuf definition of my product info type, as well as two operations. So I'm going to use get product by ID operation. So this is my service definition. Now let me go and create the code for gRPC service. Let me clean this up. Okay, so the command is quite similar to the OpenAPI one. Ballerina gRPC. Here I'm giving the input file, which is productinfo.proto, protocol definition file, and output service name. And I'm using the service mode because I'm generating the server-side skeleton, right, not the client one. OK, now it has generated code. Let's check. let's check product info skeleton. Okay. Now you can see two operations are generated. So this is where you will write the logic of the product information service. And also you can see a listener is created, which is pointing to the, let me update it to localhost and 9000. Right? And as part of the service operations, you can write, actually the types are also generated. This is the product info type that we have defined in the protocol definition, and you can use that inside my service, right? So product info, let's say it's P, and you can see all the attributes of the products are also listed. So you can basically create a new product info instance and return it back to the caller, right? All right, so let me quickly start this and see. I'm not going to implement it, the logic yet. So again, similar to the previous one, you can run product info service. Again, we don't have any implementation, but you can just simply run. So now this will expose a HTTP2 interface underneath, because gRPC is based on HTTP2. And also you can notice the listener is a gRPC listener, and service is also annotated as a gRPC service. Okay, so now in the second use case, second service, we have an inventory service. Here I'm going to use the code first approach for generating the service definition, right? So let me go to the inventory service again, right? So let me show you the inventory service implementation itself. Okay, so you can define a gRPC service, again annotated with the gRPC listener. We have defined a gRPC listener at the top. Localhost, it's running on 6061. And then I define a type. So I'll define the inventory item type with this format. And this is not a generated code. This is a code that we have written. And then you annotate that with the service config. Then you specify the gRPC operations, right? Get item. And this is my service implementation. So I'm using a sample data, dummy data to implement the service. And so the implementation is quite straightforward. You create an item object, and then you do caller and send, right, with the object. So you are basically sending the created object, because, and also as part of the gRPC implementation, you can do a complete, because you can also support streaming, right? You can do bidirectional streaming. So once you are done with the message sending, you just invoke the complete operation. So that's all you have to do. And so we don't have any service definition yet. So we don't have a proto file created for this service, although we had it for the other one, because we used the contract first approach. Now, the way that you can do is, you can go to the inventory service, right? You can do Ballerina build. Okay. Sorry. Okay. So you can do a Ballerina build, and in the now if I open up the code, it has created the target directory. So inside the target directory, we can see a new proto file created. right? So again, you started with code and a new proto file, the service definition is created. So you can share this service definition with other consumers, right? Here we have started from the service implementation, we created the service, we generated the service definition, and then you can share that with other consumers, right? So in order to implement catalog service, actually you need the service definition of these two services, right? You need the IDL of those two services. Now, if we quickly go into the actual implementation of all three services, I can go into catalog service now. Okay, so as part of the operation, so this is an open API-based service. So as part of the function show product by ID, I have invoked, so I have retrieved the incoming product ID. And I have copied the client generated client. So you can actually generate, now what we have done was server-side skeleton generation. So using this command, you can also generate the client-side code, right? So we generated the server-side skeleton using the protofiles. And also, similarly, you can change the mode to client and generate client-side stubs. So I have used that stub within my code. So if I go to catalog service, you can see there are two. This is the product info service definition, service stub, client stub. And for the inventory service, also I have the same stubs generated. So I have just copied over the generated client code. OK, so as part of the catalog service definition, we have actually invoked those. We have defined two gRPC endpoints. One is to pointing to product info. One is pointing to inventory service. And within my service logic, I have invoked these two services. Since I have generated my client-side stubs, I can directly map that the incoming values to product and inventory item. Right? This is my inventory item. So finally, I have, so here I'm doing service composition. So I'm calling product info service first, get the ID and get more details of the product, and also check the inventory on the available number of items. So it's having a service composition logic. So finally, what I have is a product instance, an object, and I convert that directly to JSON to be sent to the my consumer, right? So this is the consumer. Now let's try running this service, all three services. Okay, I'm running the checkout service. I'm running then the, sorry, this is not the checkouts. I'm running the catalog service. Then the product info service. Then the inventory service. And also, as part of the inventory service, I have used a database to implement it. Sorry, as part of the product info service, I have used a database. Now, if you look at this file, now product information is actually taken from a database, right? Now, so this is the generated gRPC code, and then I have included this MySQL connector. So I have all the product information in the database, right? And then I have defined the MySQL connector to the database that I'm using, which I'm running locally. And then as part of my services business logic, I'm invoking the select operation. So this is my SQL query. And what I'm getting back is the product info table, which can be directly casted into product info object that I'm using. This is my local object. And from that, I am sending it back to the client via gRPC. Right? So very, very simple code. So I'm not going to cover a lot about data integration because we have a session coming up in the afternoon. All right, so again, going back to the demo, let me run this again. Okay, so let's try running the service. You can see both services are getting invoked. So composition is working, and all the calls goes through gRPC, and this call is a REST call. So it's a very common use case, right? It's very possibly the most common use case with microservices architecture when you are building mostly the RESTful and gRPC service. Now let's have a look at the other portion of the integration. So here we have a checkout service, which is again a RESTful service, and it's using Kafka. So I am running Kafka locally. So I have Zookeeper and Kafka running, right? And then what you have to do here is you have to create a checkout service, which is getting a message over the REST or HTTP and publish that message into Kafka topic, to a Kafka topic. And there are two services which are subscribed to the same topic. So let's have a look at the implementation of the checkout service. I'm not going to type everything because we don't have enough time, so I'll show you the already implemented code. Now, so this is my checkout service, right? Service which is accepting HTTP and emitting Kafka messages. Now, obviously, it's a basic HTTP service, checkout context, service path, and then this is my resource. And so we have imported Kafka connector into my program. So it's coming from WSO2 package /Kafka. And then you can define a Kafka producer. So and it's again an endpoint, right? A Kafka producer endpoint, outbound endpoint. And it has details of the endpoint, such as the URL and the port, the client ID, and all the other information. So service implementation logic is quite simple. So I retrieve the request as a JSON message, and then I serialize that message into a byte stream, because Kafka doesn't care about the type or format of the data that you are storing. So we are storing data in the form of binary. And Kafka producer, if I just type Kafka producer send, so you can simply send a byte stream to the producer. So here I have passed the serialized byte array, and this is my topic name. This is my topic checkout events, and partition ID. Since I'm using a local cluster, I'm only having one partition. And for the consumer or the client, I'm sending back a 202 response, right? Because immediately after storing the message or publishing the message, I'm sending back a 202 response. So that's all we have in the checkout service. Now let me go back to the shipping service, which is So this is a Kafka consumer. Now, since you are familiar with the Ballerina's terminology on endpoints, you can obviously see this is again, it's an endpoint which is bound to the inbound channel consumer. So as part of the consumer endpoint, you have to define the URL of the Kafka server. And also the topic, because we have subscribed for the checkout events topic. And the service is actually bound to the consumer that we have defined at the top. And with the Kafka consumer type, this is how you have bound, how you can bind the service to the consumer. And as part of the resources or the operations, you get by default, you get on-message operation. So here we have defined, so as parameters, you get consumer records. So if you are building a Kafka consumer, what you get is a consumer record, set of consumer record objects. So business logic of that service is a matter of processing all the consumer records. So here I'm just printing whatever the messages that I'm receiving. Right? Again, you can see what I get as the entry is a binary array, like a byte array. Then I serialize that into to a string. So we can use different types of serialization, JSON, or you can use something like Avro to make it more schema aware. And the business logic of the order processing service, it has one more. So I don't have the database here. I just omitted for the simplicity. Here we have a file integration capability in the order processing service. Now if I open up the order processing service, what we have here is the same logic. Again, a consumer, Kafka consumer, and as part of the consumer record processing, I have actually defined this under ballerina.io, we have CSV channel. So first, I retrieve all the incoming binary byte array and convert that to string. And then you can use this CSV channel, IO writable CSV channel, so that you just pass a array of strings to the CSV channel. So it will actually write in the form of a CSV, right? So that's all you have to do. So you just get the content in a string array and just write it, right? So that's pretty simple, right? Now let's try invoking or running all these services. I have Kafka running in my local machine. Then first I'm starting the checkout service. These are my Kafka consumers, order processor. Then I have my shipping service. So one consumer, which is HTTP, and two Kafka consumers, right? All are up and running. Now I'm sending a post request to my checkout service, right? Okay, now you can see all those messages are getting published to both the services, right? The same message is coming into both of these services. And also we can check the CSV file which is generated. So you can see all the information and those things are generated in the form of a CSV. So that's basically what we have implemented. And actually, you can find the source code for the entire use case in Git repository. So I have included that in the slides as well. So So yeah, actually some part of the use case is not fully implemented, such as the databases that we have, and some of the databases are not included. But we are planning to build this as like a fully fledged use case and use this as a reference use case for Ballerina with microservices. All right, so that's basically what I had. If you have any questions, I can take a couple of them. Sorry, I can't hear you.
Talking about SOAP.
Yeah.
SOAP.
Yeah.
So I don't see that protocol.
Yeah. SOAP is, I would say, if you have something like this, anyway, even before the advent of microservices, SOAP was sort of going away because of the simplicity that JSON and REST brings you. So mostly for the consumer side, I don't think SOAP is if you are building something new, SOAP is not a good option. But if you may have a lot of internal services which are still based on SOAP, that is perfectly okay. And Ballerina also offers XML and native support for XML, as well as we have SOAP connectors, which can be used to integrate with your internal legacy SOAP services. Yeah.
I have a great SOAP demo if you want to see it.
Yeah.
Yeah. Any other questions?
Yeah.
Oh, no, that's the man with the microphone.
That's right.
All right, well, you've caught us back up onto time. I think that's
Yeah.
amazing, guys. You know, I was sat up there watching the demo, and I'm blown away. You know, in half an hour, he's integrated Kafka, Swagger, gRPC, created a scalable system. As you've seen before, you can simply create and deploy that in Kubernetes or Docker. So big round of applause for Kassan. Thank you.
Thanks.